Welcome to Cambridge IGCSE Physics, Lesson 36.1, What is electric current? Today we explore the fundamental concept of electric current, which is essential for understanding electricity and electronics. This lesson covers core content from the Cambridge IGCSE Physics syllabus, specification 0625. We'll examine how electric current relates to the flow of charge, understand current as the movement of charge carriers, and learn that current is measured in amperes. By the end of this lesson, you'll have a solid foundation in one of physics' most important concepts. Let's examine our learning objectives for today. By the end of this lesson, you will be able to, first, know that electric current is related to flow of charge. This means understanding the fundamental connection between moving charges and what we call current. Second, understand current as movement of charge. You'll grasp how charge carriers move through materials to create current. Third, recognize current is measured in amperes. The ampere is the SY, International System Unit for current, abbreviated as A. These objectives align with Cambridge IGCSE assessment objectives. AO1 covers scientific knowledge and vocabulary, AO2 involves problem solving and application, and AO3 focuses on experimental skills. Now let's define our key vocabulary. Each term is essential for understanding this lesson. First, electric current, which means the flow of electric charge through a conductor. Think of it as moving electricity. Second, charge, which is a fundamental property of matter that can be positive or negative. Electrons carry negative charge, protons carry positive charge. Third, ampere, which is the SI unit for measuring electric current. 1 ampere means 1 coulomb of charge flowing past a point each second. Understanding these terms precisely is crucial. The symbol for current is capital 1, and it's always measured in amperes, abbreviated as A. Remember to use SI units consistently in all calculations and answers. Let's explore our first core concept. The fundamental principle states that current is moving electric charge. This means electricity flows when charges move through materials. The definition is, electric current is the rate of flow of electric charge through a conductor. Rate means how much charge flows per unit time. Mathematically, we express this as I equals Q divided by T, where I represents current measured in amperes, Q represents charge measured in coulombs, and T represents time measured in seconds. The diagram illustrates charges moving through a conductor. The blue circles represent charge carriers, typically electrons in metals. The red arrows show their movement direction. The green arrow indicates conventional current direction. Notice how multiple charges moving together create the flow we call current. This principle is fundamental because it connects the microscopic world of moving particles to the macroscopic effect we observe as electricity. Now we examine the experimental method for measuring current. This follows Cambridge IGCSE standards. The apparatus needed includes an ammeter to measure current, a battery to provide voltage, a lamp as a load, and connecting wires to complete the circuit. The method consists of these steps. First, connect the ammeter in series with the circuit. Series means the current flows through the ammeter. Second, ensure all connections are secure and correct. Third, close the switch and read the ammeter display. Safety is paramount. The hazards include electrical shock from high voltages and fire from short circuits. Therefore, you must check voltage ratings before connecting and avoid creating short circuits by incorrect wiring. The diagram shows the complete circuit setup. Notice how the ammeter A is connected in series so all current flows through it. The lamp L provides resistance, and the switch S controls the circuit. Let's work through our first example. The problem states, calculate current when 12 coulombs of charge flows in 4 seconds. We are given Q equals 12 coulombs and T equals 4 seconds. We need to find the current Y in amperes. Step 1. Write the equation. We use the current equation, which is I equals Q divided by T, where I is current in amperes, Q is charge in coulombs, and T is time in seconds. Step 2. Substitute the values. We write I equals 12 coulombs divided by 4 seconds. Step 3. Calculate. 12 divided by 4 equals 3, so I equals 3 coulombs per second, which equals 3 amperes. Step 4. State the answer. The result is 3 amperes to one significant figure, with units of amperes. Remember that coulombs per second is the same as amperes. Example 2 applies the same principle differently. The problem is, find charge when current is 2 amperes for 5 seconds. The data shows current I equals 2 amperes and time t equals 5 seconds. Now we analyze. First, rearrange the equation. Starting with I equals Q divided by T to find Q, we multiply both sides by T, giving Q equals Y times T. Second, substitute values. We write Q equals 2 amperes times 5 seconds. Third, calculate the result. 2 times 5 equals 10, so Q equals 10 coulombs. Fourth, check the units. Amperes times seconds equals coulombs, which is correct. The graph shows charge accumulating linearly with time. The straight line indicates constant current. The gradient equals current. 10 coulombs divided by 5 seconds equals 2 amperes, confirming our calculation. Mathematical skills are crucial in physics. Let's examine 3 key skills. First, equation rearrangement. When we need to find a different variable, we rearrange algebraically. Starting with I equals Q divided by T, where I is current, Q is charge, and T is time. To find Q, we multiply both sides by T, giving Q equals I times T. To find T, we divide Q by I, giving T equals Q divided by I. The result depends on which variable we need. Second, unit conversion. To convert from milliamperes to amperes, we divide by 1000, so 1 milliampere equals 0.001 amperes. This is because milli means 1000th. Third, significant figures. Your answer should have the same number of significant figures as the least precise measurement in your data. This maintains appropriate precision throughout calculations. Now practice what you've learned with these 3 questions. Question 1 is basic level. It asks, current is 0.5 amperes. How much charge flows in 10 seconds? This tests direct application of Q equals 1 times T. Question 2 is intermediate. It states, 24 coulombs flows in 8 seconds. Calculate the current. This requires you to apply I equals Q divided by T. Question 3 is advanced. The question is, current 150 milliamperes flows for 2 minutes. Find total charge. This tests your unit conversion skills and analytical thinking. For all questions, remember to show you're working clearly, include units in every step, and check your answers make physical sense. Write your answers now before looking at the solutions. Physics principles power our modern world. Let's see how today's concepts apply in practice. In electronics, smartphones use milliampere currents for their processors. Understanding current helps engineers design efficient circuits that maximize battery life while maintaining performance. In medical technology, defibrillators deliver precise current pulses to restart hearts. Medical professionals must understand current to operate life-saving equipment safely and effectively. In transport, electric vehicles manage hundreds of amperes during acceleration and charging. Engineers use current calculations to design safe, efficient electric motors and battery systems. These applications show why physics matters. Career-wise, physics knowledge leads to many professions. Electrical engineering designs power systems, medical technology develops diagnostic equipment, and renewable energy creates sustainable solutions. The concepts you learn today become tomorrow's innovations. Let's review the solutions. For question 1, the answer is Q equals Y times T equals 0.5 amperes times 10 seconds equals 5 coulombs. This is correct because we multiply current by time to find charge. For question 2, we find I equals Q divided by T equals 24 coulombs divided by 8 seconds equals 3 amperes. We use the basic current equation with given values. For question 3, first convert units. 150 milliamperes equals 0.15 amperes, and 2 minutes equals 120 seconds. Then Q equals 0.15 amperes times 120 seconds equals 18 coulombs. Notice the unit conversion step was essential. Now exam success tips. First, always show you're working. Even if the final answer is wrong, you earn marks for correct method. Second, include units in every step of calculation. Third, convert units carefully. Watch for milliamperes, minutes, and other non-standard units. Fourth, read questions carefully to identify exactly what you need to find. Let's summarize today's lesson. The key points to remember are, first, the definition. Current is the rate of flow of electric charge through a conductor. This fundamental concept connects moving charges to measurable electricity. Second, the equation. I equals Q divided by T, where I is current in amperes, Q is charge in coulombs, and T is time in seconds. This mathematical relationship allows precise calculations. Third, measurement. Use an ammeter connected in series with the circuit. Series connection ensures all current flows through the measuring device. These three concepts form the foundation for understanding electric current. For further study, review the current equation and practice rearranging it to find different variables. Practice unit conversions, especially milliamperes to amperes. The next lesson covers voltage and resistance, which builds on today's work by exploring what drives current and what opposes it. Ensure you understand current thoroughly before moving forward. Remember, physics builds systematically with each concept supporting the next.